Now see next question, question number 14 from exercise 2.4. See the question. Find the largest size of a rectangle that can be inscribed in a semicircle of radius 1 unit so that two vertices lie on the diameter. Here we have to find the largest size rectangle. This rectangle inscribed in a semicircle of radius 1 unit and two vertices lie on the diameter. So we draw here a rough sketch for the rectangle. Now see here, we consider a semicircle of 1 unit. Here O is the center of this semicircle. Then we consider ABCD as a rectangle whose two vertices lie on the diameter. Suppose this diameter is PQ. So this AB lie on the diameter of this semicircle. Here we consider dimensions of this rectangle, that is length equals to x unit, breadth equals to y unit. So this O is midpoint of this AB. So here length of OB equals to x by 2, breadth that is BC equals to y unit. So here we apply Pythagoras theorem to express y in terms of x or x in terms of y. Then we have to find the largest size of a rectangle. That means area of that rectangle must be maximum. That means we have to use here concept of area of rectangle. So write here. So we write in solution here. Let x and y be the length and breadth of the rectangle respectively, inscribed in semicircle of radius 1 unit, such that two vertices lie on the diameter as shown in figure. So first we draw the figure here and we have to obtain a relation from this diagram, y in terms of x or x in terms of y, and with the help of area of rectangle we find the function for the required solution. Now here O is the center of semicircle. So right here O is the center of semicircle and ABCD is the rectangle. So in this rectangle ABCD we consider this triangle OBC. So right here in triangle OBC, this OB is equal to half of AB, that is x by 2. So right here OB is equal to OA equals to x by 2. Then BC equals to y, and this OC, that is the radius of this semicircle. So OC is equal to 1. Now by using Pythagoras theorem we write here OB square plus BC square is equal to OC square. Now OB is x by 2. So write here x by 2 its square plus BC is y. So write y square equals to OC square. OC is 1 equals to 1 square. So solve this. Write x square upon 4 plus y square equals to 1. Now we can write y in terms of x or x in terms of y. So for our convenience we write y in terms of x here. So write here, or we use here x in terms of y, that will be more convenient. So right here x square upon 4 is equal to 1 minus y square. Therefore x square is equal to, we transfer this 4 to right hand side. So 4 in bracket 1 minus y square. Now we require the value of x. So taking square root on both sides, so write x is equals to plus or minus square root of 4 is 2. So write here in root 1 minus y square. Now x is the dimension, so dimensions are always positive. So we write here x is equals to. So write here x is equals to 2 root 1 minus y square, that is positive value. Now we have to know the area of rectangle, and we know that area of rectangle A equals to length into breadth. So write x into y. So write this x as 2 root in bracket 1 minus y square into y. So squaring on both sides, we have to remove this root sign. So squaring on both sides, we get here in left hand side a square equals to square of 2 we write 4, square of y we write y square, and here square and square root get cancelled, so write 1 minus y square. So we represent this a square as the f of y. So write this 4y square. Now multiply by 4y square to this bracket. So 4y square into 1, we get 4y square minus 4 into y square into y square, we get y raised to the power 4. Now we have to find extreme values. For that we have to differentiate this function with respect to y. So differentiate with respect to y. Therefore f dash of y is equals to derivative of 4y square, we get 8y minus derivative of 4y raised to the power 4, we get here 16y cube. So we denote this as equation number 1. Now we have to find second order derivative for checking maximum or minimum value. So we differentiate this equation 1 with respect to y. So write here differentiate 1 with respect to y. Therefore f double dash of y is equals to, so derivative of 8y we get 8 minus derivative of 16y cube. So here we get minus 48y square. So for extreme values, we equate f dash of y is equals to 0. Therefore this 8y minus 16y cube we equate with 0. Therefore this 8y minus 16y cube, 8y minus 16y cube equals to 0. Therefore we take here 8y common. So in bracket 1 minus 2y square is equals to 0. Now 8 is not 0, y is not 0 because y is a dimension, that is breadth. So this bracket must be 0. Therefore 1 minus 2y square equals to 0. Therefore here 1 is equals to 2y square. Therefore y square is equals to 1 by 2. Therefore y is equals to plus or minus 1 by root 2. So this is dimension. So dimension is always positive. So we get y is equals to 1 upon plus root 2. Now here we have to substitute this value y in f double dash of y. So for that we represent this f double dash of y as equation number 2nd. So we write here therefore f double dash of 1 by root 2 is equals to, so from this equation 2nd, 8 minus 48 into y square. So y we replace by 1 by root 2. So write 1 by root 2 its square. So 8 minus 48 into, so square of 1 we get 1, square of root 2 we get 2. So here we get 24. So 8 minus 24, which is minus 16, which is less than 0. Therefore f of x is maximum, f of y is maximum at y is equal to 1 by root 2. So here one dimension is confirmed, that is y equals to 1 by root 2. So we get the breadth 1 by root 2. Now we have to find value of x. So from equation or from the relation x equals to 2 root 1 minus y square. We not represent this by equation, so we write only x equals to 2 root 1 minus y square. Now substitute y as 1 by root 2 here. So 2 in root 1 minus y is replaced by 1 by root 2 its square. So we write in root. So write 2 first. 2 in root 1 minus, here square of 1 by root 2 we get 1 by 2. Now cross multiply here. 2 in root we get 2 minus 1, that is 1. So 1 by 2, that is 1 by root 2. So 2 into 1 by root 2. So we write this 2 as root 2 into root 2. And this 1 by root 2. So this root 2 get cancelled. We get root 2 as the value of x. So value of y is 1 by root 2. That is breadth is 1 by root 2. X, value of x is root 2. So the length is root 2. So right here therefore length is equals to root 2. Breadth is equals to 1 by root 2. So for this length and breadth, the given rectangle or required rectangle here ABCD is maximum size, has maximum size.